So yeah, let's talk about infra for fully on-chain games. I'm sure you heard of a couple of talks on this, but I want to take a slightly different approach. Let's talk about Keystone, which is what we recently developed as the new flagship fully on-chain game infra. But I'll take a slightly different approach where we start from the experience that on-chain games need to or are uniquely poised to create, and then the design paradigms that can create those experiences, and finally, what infra can support those type of design paradigms. And for those of you who aren't familiar, Curio is a crypto-native game and infrastructure company. We're like basically all in on fully on-chain games, and we want to make it happen as soon as possible. And we're both building games to push forward the game design barriers as well as the infrastructure. So yeah, that will be the structure of the talk. First, a quick philosophical detour. What do you think makes the real world feel real? Is it just the rendering quality, or is there something else? And there's definitely an important piece to this, which is the social relations we have with other people. If you think about it, humans are social animals from the beginning, and the relations we have with other people are very complex. You can't really define someone as a pure friend or a pure enemy. It's very rare that that happens, and we have all kinds of interactions with people, and varying degrees of promises and agreements and contracts that happen. Now, virtual worlds today and games today have a very limited social interactions, if you think about it, compared to the real world. And why is that? Let's take a look at a couple of game models today. The first genre I would call social 1.0, which is purely PvP based, and the only social relationship that happens in these games is competition. So players fight each other. This is StarCraft, by the way. And CS:GO and Overwatch and these games all belong to this category. There's not really any cooperation, and the only thing that happens is competition, which is very drastically different from the real world. And a lot of player complaints in this category is like, one, the onboarding cost, the barrier to entry is pretty high usually because there's a lot of skills involved, and there's not that much social interaction. So, and then the next step kind of in the multiplayer genre with social relations is social 2.0, where most of MMOs are. And in this category, there are two types of primary interactions. One is cooperation within certain groups, such as the alliances defined by the game, or competition between the groups. So players are no longer just competing on an individual level, they're also cooperating within a group and competing between groups. But this is still very different from what we see in the real world, where people can act anywhere between friends and enemies, and that's what makes it interesting. So what exactly is missing, right? Let's take a specific example from the previous picture, which is Rise of Kingdoms, which is a MMO style civilization, right? When in this game, let's say the two players highlighted in two different guilds or alliances want to trade with each other. Let's say want to trade resources, two types of resources. They can't, and they also don't need to because the game is defined as competition between guilds, right? There's no need for player-to-player interactions, which takes away a lot of the fun. And this does not limit to players. That happens between guilds as well. Let's say the two guilds on the top want to sign a peace treaty for some time. They really can't do that. They can promise to each other, but if one side betrays, there's no punishment that will come, right? And that equals no deal. So what does the real world do better than games at these? In my mind, there's two very important components: the existence of highly valuable assets, such as your house or anything that makes you really care, and interaction and effective law enforcement that protects people's interactions around these assets, right? And that's why people, when you walk to work and fight your colleague over a small disagreement, you don't have to worry about them taking your house or killing you or something like that, because there's a mechanism that protects you from getting those harm. But there's not such thing in virtual worlds or games today. And I think so blockchains actually already figured out half of the solution, which is the existence of digital assets. We have digital assets that can get very highly valuable and decentralized, so it's protected. Some people might even say it's more secure than in the real world. But there's not really the equivalence of law enforcement, right? When people make promises to each other, there's not an entity that can say, okay, I will enforce these for you. And today's game, the problem is that there's not a language in which the players can tell the game engine what they're agreeing to, right? So that the game engine can take care of the promises for them. So this is like a pretty trivial example where, let's say in a grand strategy game, I don't know if you can see the text, but let's say you have a player named Vitalik right next to you, and you are equal strength, and you're fighting over a couple gold mines. And suddenly there's this player called Justin Sun that approaches both of you, and with like a lot of high-level horsemen, right? And reasonably you want to stop attacking each other for a bit so that you can both defend against this much stronger player. But let's say let's say you agree to do this for 3 turns. But in 2 turns you decided you just really want the gold mines, and you're gonna attack Vitalik anyways. What happens? Well, nothing really happens. And in fact, if everyone does that to Vitalik, he's going to quit the game and blame the game for not being designed very well. So what can make this up, right? What can allow justice to come in virtual worlds and let players not worry about worry about breaking promises and actually interact fairly with other people? Well, we designed a system called Treaty, which is actually very straightforward. It's using smart contracts to enforce social contracts in games. So basically in MMOs and grand strategy games, players are able to create or reuse smart contracts that define their relations with other people in a way that gets enforced automatically by the blockchain over some trigger condition. So what do I mean by this? Some examples of this include a simple thing like non-aggression pact, which we just showed with an example with Vitalik, to more complex things like North Atlantic Treaty Organization. You can have guild currencies that on-chain Saudi Arabias can launch to back with their oil. You can even have different kinds of governance models that govern how policies get passed. And treaties are, we think, important social building blocks for blockchain, for online games, to allow players to do exactly the social interactions that they couldn't do for a long time. And this is uniquely suited for blockchain because smart contracts already exist, but they currently don't have a function in much more context-rich worlds like games compared to things like DeFi NFTs. So yeah, we built a game out of Treaty, and we launched this January 2023, so this year. And people really enjoyed it. People made some wife jokes about this for playing the game too long and not sleeping while not washing dishes. But anyways, the game lasted for a week, and actually the end result of the game was affected by some player creating a treaty called loan agreement. They basically, the ultimate victor of the game, were able to loan troops from another player and to raid the alliance who already occupy the center of the game, which is the flag tile that is the victory condition. So that was pretty cool. But we ran into some other problems, and yeah, like I think players really enjoyed it, and we're so confident about the design space of high-stake PvP, adding on the social interactions, that we're building a real-time war strategy game with high stakes, fully on-chain, and hopefully launch that in a couple months. But I think we ran into problems as well, which is with regards to performance, right? Each transaction of our game, which wasn't that complicated, when there were 20 players playing, right? You check a couple of treaties, you check permissions, and you move people, you battle. They took anywhere from 20 million gas to a couple 100 million gas, right? And that's not even because the smart contract's poorly written. It's just because the game is so context-rich, right? You need to perform a lot of logic in one transaction. And that's why players were joking that the blue troops, which indicate movement in our game, don't actually move, and the red ones don't actually attack, because the moment of intent was just too far from the moment of execution in the games. And this is not unique to our games. This is a shared problem with all fully on-chain game frameworks today, right? Because all the logic is implemented as smart contracts that live on top of the blockchain that use usually EVM or Starknet execution environments to run the game, right? Which these systems are not meant to do. And games like Dark Forest kind of avoid this problem by designing their game in a way so that all the actions take really long time. And that's what meant to be. So, Dark Forest had energy rays taking anywhere between 15 minutes to several hours to send, which I would say could potentially works for some players. But if you want to get to mass adoption and have a lot of players who don't really care about the blockchain elements and just want new experience this is very limiting, right? And so specific problems, games are very context rich and they have much bigger transaction size. And because of that, you have some follow-on problems like stack too deep, so you have to do more gets, which even just cripples the system. And there's a lack of game tick. So what that means is, let's say if you want to move from point A to point B, the intent is moving to point B, but the actions are you might want to move many times before you get to point B. That usually traditional engines take care of using this thing called game tick, which is kind of like the sun rising every day or seasons coming every year automatically, and they don't come because someone sent a transaction that the sun would rise today. And in the same way, you move in the game, you take every step that the game engine basically take for you. You don't have to send transactions every time and check the permissions every time and check intent, which are wasted computation. And finally, Solidity is not, it's okay for smaller scale games, but to create a game as complex as some of the even medium size games in Web2, it's very, very complex. And there are much better suited languages and stacks that allow players to develop, or allow game developers to develop much faster and more stably. So because of all these challenges, we thought, okay, we wanted to preserve the social composability. We wanted to create to preserve the social composability, aka the ability to create contracts, social contracts, and the trustlessness of the logic and the assets. But also we want to add high performance and great graphics and basically all the UX stuff. So great game developers can create these fully on-chain games that will take us to the next stage, right? And that's why we created Keystone, which is a sovereign rollup based on-chain game engine framework meant to specifically 100x the performance while preserving some of the best parts of fully on-chain games. And I should need to switch screen to show the demo, but you can find this on our Twitter. Basically, we spent 2 weeks putting Warcraft 3, the game, on chain, and all the movements and battles you see with the dozens of troops moving and attacking at the same time, sub-second level, happen in real time on chain, right? And all the logic are on chain. So that's like a huge step from what we see today with today's frameworks, including our past framework with Treaty. So key features of Keystone include its high throughput ECS-based game engine. ECS just states the way game data is stored. And it supports the fast game tick supports classic RTS style games like Age of Empires. You can theoretically, for a fairly simple game, get to 60 ticks per second, which is pretty much all you need, right, for a close to very, very real type of experience. It supports historical state querying, so you can write treaties such as if something didn't happen for 3 turns, then whatever reward that is or punishment. This is not about the current state; it's about historical state. And finally, it supports EVM-based treaties. So treaties still use Solidity, but use precompiles to get and set certain states. And finally, it's written in Go. So basically, I'll talk about the architecture. You have the game logic that lives on the same layer as the EVM. So it's not really fully on-chain, but fully in-chain. Because if you think about it, the digital physics or the game rules don't really change that often, just like the EVM layer, right? And what happens is the EVM supports all of the social contracts players make with each other in real time, whereas the game tick and a lot of the like indexer and a lot of other features that blockchains currently don't have with games are added in parallel with the EVM and interoperate with custom stateful precompiles. And this whole system settle data to Celestia DA for anyone to basically observe and be able to challenge the validity, and also to Ethereum for payouts and the asset-related features, right? And basically, there will be a multi-sig of guardians that are basically sequencers of this whole thing. and the multi-sig is able to kick out, to vote out anyone who acts maliciously and based on players' input. So yeah, and this is like we basically open sourced this by the end of May, and we're in the process of still improving the system, coming up with Keystone v2 probably in the next couple of weeks. We want to, our game is obviously built on top. We're getting more people who are interested in building on-chain games that are not just hobby projects to build on top and to really impress people. So yeah, definitely welcome all suggestions or questions here. But yeah, we think this is the first step toward games that have massively complex social relations like Ready Player One that also have highly valuable assets. This is what we don't have today in today's virtual games. So yeah, we're building Keystone v2. We're working on the flagship game, which is the high-stakes strategy game. And ultimately, we are, as I said earlier, like the game space that fully on-chain games open is massive. And we alone cannot possibly explore even probably 5% of everything. And so, but in order for games building on Keystone to succeed, we can't just host hackathons. We don't think that's enough for a game. Like you have to worry about so many things like art, distribution, and capital. We will provide all of that for you. As long as, like if you talk to us, we'll like figure out what's the best way to be on chain for you, what's the tick rate design, like how do you settle data, how do you get your initial group of players. We'll even match you with the art teams we have for basically much better looking games than today's on-chain games. We'll support you with all of that so you can focus on the mechanism. So yeah, that's everything. I think we're slightly over, but I think we can take some questions. Yes, Northwell. Oh, okay, you're next.
Hey, great presentation, thank you. So I'm just curious, in terms of the users for these games, right? Who do you think this appeals to primarily? Is it your hardcore on-chain gamers, like the ones who play Dark Forest? Or is it more crypto gamers, who are like your Axis, etc., who are probably there more for speculation? Or do you think there is a pathway for this to get entirely non-crypto gamers from outside who are both mobile or console-based, right? Just curious, where is this going from a user standpoint?
Yeah, that's a great question. So we're solving a very fundamental user need, and it's more on the psychological rather than technical side, where we're attracting players who are generally very willing to, who are interested in highly PvP types of games with high stakes, and at the same time, perhaps are looking for more complex social interactions in online games. So imagine if you're a competitive Dota, if you're a really good Dota player, but you're not competitive, so you're not enough to participate in esports, right? But you still really want to play RTS games and play with stakes with other people, right? And perhaps win or lose based on your skills. And you want to improve your skills so you can perhaps earn more, right? That's the type of people that we think we will attract. That's obviously an hypothesis, right? We still need to test it, but it's drastically different from today's blockchain or like Web 2.5 gamers who are, I would say, looking for asset appreciation, which is unsustainable. It might have a big overlap with today's fully on-chain players, but not perfectly, because I do think a lot of fully on-chain players today are only interested in the technicals, but are not really looking for a good experience. I do think the ultimate goal is to get people who, for example, like StarCraft or like poker, right, and like basically fit the criteria I described earlier to come, right? And we need to basically solve a lot of problems before that comes true.
Okay, thank you.
Yeah.
Okay, I got one technical and one social question.
Let's do it.
My technical question is, in my mental model of like time it takes chains to execute thing, like the bottleneck is really the merkleization, like committing to the state.
Yeah.
Yeah, any form of commitment. Like how do you do that Because you manage to bypass this bottleneck by doing something clever, or don't you
Yeah.
state routes or something?
Yeah, that is the slow part. You're right. And there's kind of different ways to think about it. If you need real-time settlement, I don't know, every like on a sub-second level, I think you might just like that might just have trade-offs with how complex the game can be. Or alternatively, you can have kind of a challenge period after, let's say each game lasts for 3 days or something at the beginning, right? I don't think we'll have like very persistent games at the beginning to have strategic depth. In that case, you can have a challenge period after the game so that people can run the game over, right? After the data is settled, Merkleized and settled, and make sure that everything's this fair, and then basically the payout then happens. So I think it really depends on the specific game setup that you have. Yeah.
So
And also this is not like, this is very early. Like we haven't thought too much about consensus of like the Merkleized data. That's a hard problem that I think we're thinking about. So yeah.
yeah, so the idea, if I'm correct, is that there's some outcomes that you care about, like this player won and maybe these resources shifted after the game.
Right.
And so the game nodes will commit to that, and then you can sort of challenge that these are not the correct outcome, but you don't need to Merkleize the whole state with all the health at any point.
Right, exactly. We could Merkleize the whole state if it's, you know, if it's doable. Yeah.
Yeah, yeah,
needed.
definitely interesting question there. The other one is like, okay, so the premise of your game is, well, not the premise, but like one of the big features is you want the smart contract agreement between player. But don't you think that sometimes like the sort of drama of it is what gets people hooked? You know, like the betrayal and the like game theory of it. Like, oh, I have this agreement with this guy, but I need to watch my back because he might betray me. And then, if he does, his reputation is gonna be ruined, and it's like sort of a iterated game thing. Like, don't you think that's worth preserving some of that, or I don't know, how do you think about that?
No, this is a key question. So let me just ask you, right? Let's say like you're, you know, in today's corporate world, right? Everyone signs contracts like NDAs with each other and like freaking like I don't know whatever other types of contracts. But there's still tons of betrayal that happen, right? And they are basically kind of like loopholes of the contract that gets exploited, and that makes the whole betrayal more interesting. So let's say I sign a non-aggression pact with you. It doesn't say I can't have a vassal state that can attack you, right? I can pass the troops to them to attack you, right? That's something. So we're creating these structure for very blatant violations to be impossible, but you can think of, it basically requires players to think on a higher level and like betray on a more interesting level, if that makes sense.
Yeah, that's interesting. That's cool.
It's definitely like the goal is definitely not to avoid any social relationship change. In fact, it's to encourage that, but by freeing a lot of the minute or like the small things to worry about. Like if I want to do a trade for 3 turns with you, I don't want that to be broken if I'm doing that with like 500 other players. But then I can think strategically like, oh, like maybe what vassal state should I set up over like the next 500 turns to have what kind of XYZ goal.
All right. So like you're actually expanding the design space of the interaction that are possible, because there are things you would never ever do if you couldn't trust people.
Yes, and there are also things such as, you know, we probably won't allow permanent non-aggression pacts, just for the reason you mentioned, right? Okay. You know, we can have all treaties time bounded to like 500 seconds or something like that. That's also a pretty like straightforward thing to do to limit the negative consequences.
Cool.